So let's look at what the patterns for macroevolution are, okay? Where we look at genetic drift, sorry, genetic drift, mutations, natural selection, gene flow, where we get all that in a few thousand years with microevolution. Macroevolution takes all that and basically injects a buttload of steroids into it and looks at it on a much bigger scale. Sometimes it's really hard to see gene flow when everything's been extinct and dead for several millions of years. So when it comes to macroevolution, we think of this: stasis, character change, speciation, lineage splitting, and extinction. Okay, these are the patterns for macroevolution. These are not the patterns for microevolution. That's the Hardy-Weinberg equilibrium. Patterns for macroevolution are these one, two, three, four different things right here. Being able to explain them maybe makes a good short answer question on an exam. I'm probably just going to ask maybe one or two. When it comes to stasis, guys, stasis involves the concept of change. If a life form exhibits very little change, then that is being referred to as stasis. Okay. And that's all that stasis means right here. Stasis means does not change much over time. Now, there are a number of creatures that exhibit this phenomena where they don't have a huge amount of change that has occurred over the millennia. You know, sponges, phylum Peripher right there, not much change. A whole hell of a lot of no change. Dinoflagellates, a whole hell of a lot of no change. All right. There are coelacanths that have exhibited not a whole heck of a lot of change where they come down here off of the vertebrate tree right here and branch where they don't necessarily exhibit a whole heck of a lot of change. And sometimes those are referred to as living fossils, where they have been found in the fossil record and they have been found within certain layers of the sediment to suggest that they were around for a very long time, not found, not seen, no record of it for us from a first-hand account, so it can't be micro. We just assume that they are extinct. Obviously, sponges easily seen on the ocean floor, dinoflagellates easily seen in different waters. Coelacanths were thought to be extinct and then discovered in 1938, and it was assumed that there was like 80 million years of some kind of extinction for these creatures. So, you know, pretty interesting. But when you look at their skeleton, they look exactly like the fossils discovered from 80 million years ago. That's a hell of a lot of stasis. So these things haven't changed much, if at all, over the course of time. They just haven't been stressed by their environment to change and adapt. And many things, as you can see from that tree of life, have not. The second thing is character change. Character change is change, either very quickly or slowly. Now, when it comes to these things, when it comes to evolving a change, it could go in a haphazard pattern, as you can see from here, over here in branch A. We have quick change. Well, we have some change and then quick change and then quick change and then quick change. And there's no necessarily rhyme or reason here. Okay. Rapid change, no particular direction. For lineage B, here we had a change in the character, a change in the shape. Okay. A change that caused a either gaining or losing of segments, like I have up there in the verbiage. Here is much slower. In a direction here is, maybe a little bit quicker. Okay. But this is a much more steady, gradual change that has occurred over time, and there's not these sharp directional formats and changes that have occurred in the body plan or the body shape. This is going to dovetail into something that we'll talk about here in a little bit towards the end. But when you have very punctuated, rapid changes, it may be easy to see those, and you may think that it could be a whole different species, even though it's the same species. They're just these rapid adaptations that have occurred over the course of the millennia. With B, what we started out with, it may look completely different at the end there. There may be some intermediates along the way that have occurred. Okay. And when we find those, we get a better idea of character change. If we don't find those, we can see gaps and spaces within the record of this different species. And that's what you see with the human population, with the Homo sapiens. Sometimes it's difficult to see those subtle changes that have occurred within the character of an individual. Lineage splitting refers to speciation. We just talked about that in the previous lecture there. This is the final result of what? Genetic information. Genetic information being so different that it results in the splitting of a species. Now, for this one, it goes to, looking at a fossil record, understanding extinction patterns, okay, understanding biogeography, understanding changes that occur to an environment over the course of time. To that event here, excuse me, we can have very different lineage splitting or speciation occurring within a group of individuals. Okay. And the first clade, the first group, okay, you can see here has undergone unusual frequent speciation. Okay. Common ancestor, and we get a vast number of various different species off that one. In the middle one, we see very few, okay, an unusually low rate of lineage splitting, okay. You can see we have a common ancestor, and we've only have 2 different species that have resulted from that lineage splitting. Or we can get a burst of species that have occurred. Okay. Here we have 3 different species that developed here off of this common ancestor. And then boom, something happened and we get a burst of species formation. What causes these things? Here we can see we don't have a burst all at once, we get random. Here we had a splitting. And here we have some different subspecies forming here at various different times at various different rates. What causes this? Why was this one all at once? Why did this one produce a bunch of random irregular? Why was this one very uniform? Very little change. That should be the question that you ask. And that's the question that scientists ask when they see these type of different speciation events. It can be very slow and methodical, okay? And this is what alloperic speciation is, okay? A subtle change in environment. This is microevolution. This is basically what we talked about the other day when we looked at the different subspecies of snakes. They're adapted for their individual locations, their individual environments. If I can get enough of this change to occur over a long period of time with isolation, I can get reproductive isolation to occur. And when reproductive isolation occurs, I get the formation of a different species. If we look at the difference between this salamander here and this one here, well, if this mountain range becomes impossible to pass over, and we add millions of years to the separation between these two different subspecies here, we can get a change and we could get a lineage splitting. What if all of a sudden there's an upheaval? What if there's a massive change? What if there's an earthquake that quickly creates a massive gap, a massive space here? Well, that's going to speed up this situation here of no interbreeding between these two different subspecies here. And it's going to allow them to be genetically isolated, therefore giving rise to two different species. Okay? But environment. What did we talk about ad nauseum with microevolution? It's all about adapting to the environment. And here, alloperic speciation looks at that. Symperic speciation. This is when, this is when one population develops into two or more reproductive or isolated groups. The difference between alloperic and symperic is that there is no prior geographic isolation here. Okay, you truly get an adaptation that occurs because of a subtle little change that happens very quickly. That's probably the very most simplistic way to explain that. Okay. Rapid change. The last one here is convergent evolution, and I introduced this concept in the first lecture there in chapter 15. Similar function, different organ, bat wing and a bird wing. These two things were two unrelated species where they both had an environment that they adapted to and created different wings. One adapted from one line, one adapted from another species line, and ultimately became the same function. So that's convergent evolution, and we talked about that in the chapter 15 lecture. The last major thing, guys, is extinction. This is probably the most important aspect when it actually comes to evolution. The struggle to survive the environment is a hallmark to Charles Darwin. All of his predecessors that he pulled upon, some of them, it was the struggle, it was the war, it was the famine that you had to survive. And in macroevolution, extinction plays a very, very, very important role. The extent of the extinction event will dictate the amount of species that end up losing their spot at the table. Okay. If we have a massive loss of life like that occurred with the extinction of the dinosaurs, you had a huge amount of plant life that went away and a huge amount of very large animals that relied on those that started to die. And then you had a very large number of metasauruses that ate the plantasauruses and they started to die, and that creates a massive void in an environment. Those creatures that are now smaller are going to start to thrive. They can come out of hiding. They can get out there and get access to food. They don't need to eat a whole hell of a lot of food. So even if we have an extinction event like an asteroid hitting the planet and putting a plume of dust in the air that blocks out a lot of the sun, I don't have to have so much sun to have all the plants flowering. I only need a small number of them. because the animals that now exist are a heck of a lot smaller. And that's what we see here. Okay. Here I see some haphazard speciation, some very haphazard, various different species that popped up here over the course of time, and then all of a sudden, bam, extinction event. To where it killed off all these players here. Okay. And these guys were best adapted to the now changed environment on a very rapid scale. And so they continue on. And extinction events are what shape a lot of the fossil record and the animals that did survive and plants that did survive.